The illustration shows a propeller rotating in line with its plane of rotation. A propeller generates thrust by accelerating a mass of air rearwards. The equal and opposite reaction from the rearwards acceleration of air drives the aircraft forwards. During this study, we will view the propeller from above. To show the detail, we need a closer look. Some of the following definitions will be familiar to you from your study of piston engines. Our first definition is the chord line. A straight line passing through the center of the leading edge and the center of the trailing edge of the propeller blade. Here's the plane of rotation, an important reference for the study of propellers. You can imagine the angle of the blade to the plane of rotation, enabling the propeller to accelerate some air rearwards. This angle is called the blade angle, or pitch. Operationally, the term pitch is used more often than blade angle. Let's have a look at an individual propeller blade. The blade is attached at the root. The blade tip is at the other end. The leading edge of the blade is at the bottom, and the trailing edge is at the top. The blade has an aerofoil section, which, from root to tip, is at different angles to the plane of rotation. When a propeller blade is shown in a diagram, the view is of the aerofoil section at the reference station, 75% from the root. You can see that the blade is twisted. The blade angle at the root is larger than the blade angle at the tip. The reason for blade twist is that the tip is moving faster through the air than the root. If there were no twist, the tip would generate more thrust than the root and would stress the blade. Blade twist gives an even thrust generation from root to tip. Once again, a view of the propeller from above. We need some room to show the next item, geometric pitch. Geometric pitch is the theoretical distance a propeller would advance in one revolution at zero blade angle of attack. As the definition says, it's a theoretical distance and impossible to achieve in practice. A propeller is a very efficient machine, so, under ideal conditions, it could advance at its effective pitch. The difference between geometric pitch and effective pitch is called propeller slip. The angle between the actual path of the propeller and the plane of rotation is called the helix angle. The next lesson will outline details of the fixed pitch propeller.